Alright, moving on to section B of chapter 6, doing problems 1 and 3. So first one gives us a third term and a seventh term of this geometric sequence. So I use the geometric U of n formula to get the setups for that. So we have the third term is 7/4, we have the seventh term is 4/48, and then we are to figure out the first term and the common ratio. So sometimes we use an A, sometimes we use a U for the first term. It really doesn't matter. They mean the same thing. So two options on this. One would be to work with those two equations and solve that system with substitution. So for example, if I wanted to isolate U1, I could take r squared and divide it over to here. So 7/4r squared equals U1. I could then sub out U1 for 7/4r squared and go from there, and that would be fine, but there is kind of the cool little trick of just doing a little shift. If I take my third term and my seventh term and bump them down 2 places, this becomes my first term, and that would become my fifth term. And then now it's like you already know the first term in that setup, so it makes it easier to solve for r. So that's what we're going to do. We're going to do a little shift, and I'm going to say, let's bump this down to my first term and bump the other guy down to my fifth term. So I shifted them both down 2 places, and now I'm going to go from there. So now I'm going to say, okay, the fifth term, so 4/48, is equal to my first term times the common ratio to the n minus 1. In this case, it's 5 minus 1, so r to the fourth. Now I can just multiply by 4/7 over to here, and then take the fourth root of that number to get my common ratio. And so if you did that process, looks like we come out with a common ratio of either 4 or -4. So remember, anytime you take an even root of another number, you're always supposed to throw in a plus or a minus. But in this case, because they alternate signs, we know it has to be the negative version of that answer. So that's why our common ratio is -4. Now that we know our common ratio is -4, I can now sub it back into one of the proper equations, where this was actually the third term and the seventh term, to figure out what the real first term was. So now I would just go with maybe this one right here. That looks easy enough. So now I'm going to plug back into that equation, and we'll call it A, times my common ratio to the 3 minus 1 power, and now we can solve that for A. So if you take the 16 and divide it over, we can get our first term that way. So we get our first term of 7/64. So now we know our first term, know our common ratio, and we can use those to move forward in the problem. So figured out that first part. Now we want the fourth, fifth, and sixth terms. So there's a couple ways you could do that. You could use formulas and do each one individually, or you could just kind of use a little common sense here. Knowing that the seventh term is 4/48 and this was the common ratio, I can just work my way backwards to get the 3 previous terms, or work up from the third term, which would probably be the easiest route to go, I guess. So in this case, again, we know the third term is 7/4. So if I multiply that by -4, I get the fourth term. And if I multiply that by -4, I get the fifth term. And if I multiply that by -4, I get the sixth term. And so that would be the easiest way to do that one. So we're not going to work that one out just because that's just simple calculation to do that. Part C, they are now asking us to find the sum of terms 4 through 12 according to the rule that we now have. So remember the sigma notation, that always represents a sum. This is the term you start with and the term you end with, according to the rule that we are working with in this problem. You can do that by hand if you really wanted to. You could use a formula to do a geometric sum formula. If it was a case where you weren't able to use a calculator for something like that, then you would just want to make use of the formula. I would plug in a 4 in order to get the fourth term. You plug in a 5 to get the fifth term, 6 to get the sixth term. You just kind of plug in those numbers, although we already know what most of those are. so that because of what we did here. So you could do a few more by hand and figure out the numbers that you need to add together. That's an option. We also do have kind of a cool calculator feature that we can use as well. See if I can block that glare for you. So remember, if you go under Math and go all the way down to the one that says Summation, we get that feature right there, and that just allows us to plug in what we need. In this case, n equals 4. That's the same thing as saying x equals 4. Up top, it wants us to go through term 12, and then down here we just type in the rule. So we know the first term is 7/64. I'm going to play it safe with parentheses here, so 7/64 in parentheses times a common ratio of -4, and then that is being raised to the n-1 power. Oops, there we go, sorry. And again, we're not using n on this, we're using x because it's the calculator, so I'm going to put x minus 1 as my exponent. So there we go. So that's the entire rule, and anytime you're using this feature, you got to make sure that the entire rule is in one big set of parentheses for that to work right. So that's the way I would type it in, and that would be our sum. All right. So moving on. Going down here to the second part, so the nth term of the sequence is given by this, where n just represents a term number. So find the value of the 32nd term. So that one's going to be pretty straightforward. All you have to do is plug in a 32 for n to get the value of the 32nd term. So if you did 5 times 32 plus 18, that should give you that value. So write down an expression for this and simplify it. Explain why it's arithmetic. So what this notation is really telling you is, notice this is just n, and that's n plus 1, which means whatever that term is, that would be the next term in the sequence. When something is arithmetic, you can always subtract backwards from any term minus the previous term to figure out the common difference in an arithmetic pattern. And so that's really what's being described by this. So for this one, to just kind of work with what we really got, to get the expression, so u of n plus 1 would mean 5 times n plus 1 plus 18. So 5 times n plus 1 plus 18. So I have that expression minus u of n, which is just the 5n plus 18. Squeeze all that in there. So that's what they're wanting us to show. And then we're just going to do a little cleanup on that as best as we can. So we got the 5n plus 5. That plus 5 will combine with the plus 18. So let me write that as 5n plus 23. And again, I am doing that minus this one. So obviously the 5n minus 5n would cancel. 23 minus 18 is going to come out to be a 5. And there we go, we have our common difference of 5. So we know it is arithmetic because the difference between any two terms is 5. And so we showed that by showing that with the general expression, that that's what we are always going to come out with that difference. So moving on to part C. So now they're talking about the sum of the first n terms, so write down an expression for that and simplify it. So in this case, because it's an arithmetic pattern, I'm going to use the arithmetic sum formula. So for this one, this is where you got the n over 2. So 2 times the first term plus n minus 1d. So we can now get an expression for that by just plugging in what we know. And it says the first n term, so we just want us to leave n as n. So I'll keep that as it is. We figured out the first term, or we can figure out the first term by just plugging in a 1 back up into this expression. So 5 times 1 plus 18 is 23. So 23 times 2 is going to give me that part of it. And I'm going to keep n as n, but we do know now the common difference is 5 from the last part of the question. And then so now we're just going to clean that up as best as we can. So right here I have 5n minus 5. The minus 5 and the 46 are going to make 41. Distribute. So 41 over 2n. And then right here, I'm going to have the 5 over 2, and then the n times n, or n squared. So there's an expression we can use. Sorry, I didn't realize I was dropping off the page. So there's an expression that we can use for any sum. So now it's like, because I developed that general expression, now if they said something like, what's the sum of the first 10 terms, I could just plug in a 10 for n. Or the sum of the first 20 terms, I could plug in a 20 for n. So now that's easy to use now that we have that general expression. This one in particular is asking us for the sum of terms 18 through 35. So this one's a little tricky to think about. First things first, they don't want all 35 terms. They only want from terms 18 to 35. So what we're going to do on this, in order to work with this expression, is we're going to find the sum of all 35 terms and then subtract out the first 17 terms. And that's going to leave me with just this group right here. So it starts out by just finding the sum of all 35. So using our expression from down below, I'm going to replace n with 35. So that setup is going to get me the sum of the first 35 terms. But we don't want all 35 terms. We only want from 18 and above, which means I got to get rid of the first 17 terms. So I'm going to now subtract out the sum of the first 17 terms so that I'm left with just that group right there. So now if I plug in the 17, sorry, I'm going to drop off the page here, but fit it on there as best I can. There we go. So now I'm plugging in the 17. And so what you're seeing on that setup again is I have the sum of the first 35 terms. I'm now going to take away the first 17 terms, and that's going to leave me with terms 18 through 35. And so that's our setup right there. The rest of that is calculator work, so that's just something you can put into a calculator. Last part on that question, so determine the number of terms of the sequence, which is equal in value to the 7th term of the sequence in part I. So this one is now back to just a specific term number, no longer a sum. So this one says the number of the term in this sequence. So remember, this sequence was defined by 5n plus 18. And I'm leaving n as n because they're asking me for a term number. And they said it's going to equal the 7th term in part I. And if you remember back up here, the 7th term was 448. Which means I can now just set that expression equal to 448 and solve for the term number that goes with it. So subtract that 18, divide by 5, and that's going to get you your term number. All right, we're going to move on to question number 3. To wrap it up here, so now they're giving us a sequence. On this one, they're not telling us the specific terms, they're just giving us expressions for each term. So for the first part, so they're telling us that when x is 7, the sequence is geometric. So figure out the first 3 terms. So if I start plugging in a 7, I can get the first 3 terms. So 7 minus 3. If I plug in a 7 right there, 21 minus 1. And plug in a 7 right there is 100. So now they're saying find the common ratio. So you can see we are multiplying by 5 every time to get the next term, since they're calling it geometric. So we got our common ratio. Remember, if you're ever not sure, you can take any term and divide it by the previous term to get a common ratio. So find the sum of the first 11 terms. So now again we're this one's now been identified as geometric, so we're using the geometric sum formula. So for the first 11, so we're going to find the sum of the first 11 terms. We got our first term. So we got r to the n minus 1 over r minus 1. So right there, that can just go straight into your calculator to find the sum of the first 11 terms. I'll let you do that one. Moving on, find another value for x for which the sequence is geometric. So a little tricky on this one, but here's how we can do that. So for part B, keep in mind that in a geometric sequence there is a common ratio, which means this term divided by this term must equal this term divided by this term, because there's a common ratio. So I can now take the second term divided by the first term, and that would have to equal the third term divided by its previous term. And so we get that look right there. So again, that's all based on the idea that there is a common ratio within this process, which is why it's geometric. From there, I would just cross multiply in order to continue the equation to get rid of those fractions. Here in the worked out solutions is what that looked like when we started doing that. So we cross multiplied to get this look that you see right here. Once you start doing some cleanup, get it all on one side so that it equals 0, and you're solving a quadratic. So keep in mind, out of this you're getting two solutions. One of them is 7, the other one is -1/5. The question that this one asked was, find another value for x. We already knew one of those values was 7, so we are finding the other value, which is the -1/5. And so that becomes our answer for that one. So then moving on here to this last part. Alright, so for part C, so for this value of x, so now we're using that -1/5 or -0.2, find the common ratio. So we would just start by plugging that in for a couple numbers to get a first couple terms. So like when we did the first part of this problem, we plugged in the 7 to get those first 3 terms. And then remember, you can do the second term divided by the first term in order to get the common ratio. So we're going to do the exact same thing now for part C, but instead of using the 7, we're now using the other value of x that we just found, which was the -0.2. So I'm going to plug a -0.2 in for this to get the first term. I'm going to plug a -0.2 in for that to get the second term, and then I can just do the second term divided by the first term in order to get the common ratio. And so that's what you were seeing in the worked out solutions for this part. And so that's what you're seeing right here. So into the second part of the expression, right here, they plugged in the -0.2. Into the first term, they plugged in the -0.2. And then they're doing the second term divided by the first term in order to get the common ratio. And so that's where that 0.5 is coming from for CI. And then on the very last part, find the sum of the infinite sequence. So remember the infinite sum. So our infinite sum is just the first term over 1 minus the common ratio. So we just figured out the common ratio in the last part was 1/2. So that's what we got for that one. And then the first term, so when we took our -0.2 and plugged it in right there, that's how we got the first term. So the -0.2 minus 3 is what gave us the first term of that sequence. And simplify that, and we have our infinite sum.